Welcome to the Canadian Beef Cattle Podcast, presented by the Beef Cattle Research Council. The most popular content from beefresearch.ca, available on the go. Before we get into this week's episode, a quick message from the BCRC.
Understanding the principles of low-stress weaning helps beef producers choose a method that fits their operation, while reaping the benefits of reduced disease risk, lower treatment costs and time, improved weight gains, and a quieter barn. There are two common low-stress weaning methods. The first is fence line weaning, where calves are separated from cows on weaning day, but remain in adjacent pens to allow visual and nose-to-nose contact without nursing. The second is two-stage weaning, which uses a temporary plastic nose flap to prevent nursing while calves remain with the cow, easing the transition. Learn more about low-stress weaning strategies at beefresearch.ca.
Hello, I'm Kristen Thompson with the Beef Cattle Research Council. Now that cattle feed is harvested or being harvested, it's time to start thinking about testing that feed. While visual assessments can help separate the good quality feed from the poor quality feed, it is not going to help you determine the energy and protein content. Only a feed test can accurately provide this information. For the most accurate results, it is best to test your feed shortly before cattle consume it, or when management decisions are going to be made. But you'll need to leave adequate time for the results to come back so that you can plan for supplemental feed if it is needed. For example, if you harvested your feed at the end of August and sent the sample off mid-September, then you should have your results back by the end of September at the latest. This gives you enough time between then and when you start winter feeding to source any supplemental feed that you might need. So what are some of the benefits of feed testing? 1, it allows you to develop appropriate rations that meet the nutritional needs of different classes of cattle and different stages of production. 2, identify nutritional gaps that may require supplementation, including trace minerals that may be deficient in cattle from across Canada, such as copper and selenium. 3, it allows you to prevent or identify potentially devastating problems due to toxicities such as mycotoxins, nitrates, sulfates, or other minerals and nutrients. 4, it can help avoid production problems such as reduced conception or poor gain caused by mineral and nutrient deficiencies or excesses. 5, it can help economize feeding and possibly make use of opportunities to include diverse ingredients such as fruit and vegetable waste. And 6, it can help you to accurately price feed for buying or selling. Accurate knowledge of feed quality, particularly the operation's forage base, allows beef producers to develop feeding strategies for specific production scenarios and minimize over or underfeeding of nutrients. By doing so, one is able to achieve desired production targets and save on supplemental feed costs. So now the question is, how do you collect appropriate feed samples? Any feed type that will be used to feed beef cattle can and should be analyzed at a lab to ensure the nutritional needs of livestock are being met. This includes silage, bale forages and straw, byproducts, baleage, grains, swath grazing, cover crops, and corn. The amount of sample to send to a lab will vary based on lab specifications. Typically, a 1-quart zip-style plastic bag is enough sample. However, more may need to be sent depending on the number of tests requested. Reach out to your chosen lab to see if they have specifications for the amount of sample. A list of Canadian feed testing labs can be found in the link in the show notes. Let's go over how to sample different types of feed. For baled forages, first, group the forage to be sampled into lots. Now, these lots could be based on forage maturity, variety, harvest date, a single field, or it could be even a single cutting. Using a forage probe, collect the minimum recommendation of 20 cores for each lot you wish to submit. Once you have the sample collected, put it in a plastic zip bag and clearly label it. Samples should be stored in a cool location, such as a refrigerator or cooler, with ice packs until shipping to the chosen lab. For silage and high moisture grains, there are different recommendations for sampling depending on the type of forage system used. If the silage is stored in a bunker or pit, the face should be scraped using a loader or shaver to create a fresh pile for sampling. Collecting hand-grab samples directly from the face is not recommended as this presents a safety hazard. Hand-grab samples can be collected across the face of silage when it is stored in a bag, and you want to collect the samples in a W or M pattern. If collecting from the side of the bag using a forage probe, holes should be sealed afterwards to preserve forage quality. When stored in an upright silo, allow the silo unloader to run for several minutes prior to collecting the sample. The sample can be taken from a pile made from the silo unloader or out of a feed cart if directly loading into the feed cart. Do not sample from the 2 or 3 feet at the bottom or top of the silo, as this silage will be spoiled. Additionally, fresh silage can be sampled, and hand grab samples can be collected from each load throughout the day of harvest. Sampling fresh forages gives you advanced knowledge of the nutritional quality of the stored forage. The fiber and protein fractions should not change significantly following harvest if proper ensiling and fermentation has occurred. Once you have collected the silage or high moisture grain sample, mix the samples in a clean container to create a composite sample, then subsample this for analysis. Seal the composite subsamples in a plastic sample bag, seal, removing as much air as possible, label, and store in a freezer until shipping. If you are sampling swaths for grazing or standing forage, obtain representative samples of the swaths or the whole plant from approximately 10 to 20 locations throughout the field. Chop the sampled forage into 2-inch pieces, mix and divide into composite subsamples for analysis. Remove air from the plastic sample bags and store in a freezer until shipping. For grains, pellets, or alternative feeds, 10 to 15 samples from each truckload or bin should be collected using a clean sample probe or scoop. Samples should be collected throughout the load, representing a good cross-section of the truck or at a regular frequency throughout the unloading process. So you've collected your sample, sent it away, and now you've got the results back. But how do you interpret them? Most labs provide basic information on protein, moisture, energy, total digestible nutrients, or TDN, fiber, and some minerals and vitamins. More specialized tests may include results for nitrates, toxins, relative feed value, and other parameters. The BCRC's tool for evaluating feed test results allows producers to see how a single feed meets the basic nutritional requirements of different classes of cattle in different stages of production under normal circumstances. A link to this tool can be found in the show notes. Laboratory results are often reported as both dry matter and as fed. Dry matter refers to the moisture-free nutritional content of the sample. When formulating, always formulate rations on a dry matter basis. So we've gone over some information on how to collect a feed sample, where to send it, and what some of those results may look like. So what do you do now in order to get started? First, do you have the right tools in order to be able to collect a representative forage sample? Assess your feed resources. What types of feed are you planning to use, and which tests best suit your forage type? Do you want a standard feed analysis or a more specialized one? Evaluate your goals for feed testing. What is motivating you? How do you plan to use the results? Have you considered contacting a nutritionist, agrologist, or veterinarian who can work with you to help interpret the analysis? Are there potential risk factors you are wanting to avoid with the feed you're feeding? For example, are you concerned about the risk of mycotoxins in barley or nitrates in a crop that was stressed? Have you or your neighbors had particular problems in the past? You also need to understand the realities of potential results and study your feed options. If your feed is poor quality or contains potentially dangerous toxins, how can you use it best? Do you have experience using poor quality forage? Do you understand the risks of using potential problem feeds? Consider budgeting your quality feed for the higher production requirement periods. For more information on feed testing, quality, and analysis, you can visit the BCRC's webpage, and a link to that webpage is included in the show notes.
Thank you for listening to this week's episode. You can find all relevant links and information at beefresearch.ca or in the show notes. The Beef Cattle Research Council is funded by the Canadian Beef Cattle Checkoff and strives for excellence in the production of Canadian beef, cattle, and forage through research, innovation, and extension. Tune in every Tuesday as the Canadian Beef Cattle Podcast delivers straightforward insights, expert information, and a wealth of practical knowledge for Canadian beef producers. Subscribe now.